All right, so welcome back again. Um, Today I want to look at some examples. On our previous lesson, we talked about some uh, trigonometric ratios. So in this lesson, we're going to use these ratios that we talked about in the first tutorial to solve some basic examples. All right. So we have an example one, um, which is saying that figure 2 shows a right angle triangle with vertical, horizontal, and diagonal heights measuring 5, 12, and 13 units. So we have 5, 12, and 13 units. Now we have to find sine A. Sine A, sine A, cos A, tan A, sec A, cosec A, and cot A. Alright, so basically in our previous video we talked about how to use this right angle triangle to determine the side. Now the side which is facing the right angle side, which is always the highest or the longest side, is called the hypotenuse. So let's use it to represent that hypotenuse. Now if the angle is placed here, if I have an angle alpha placed here, now the place it is facing becomes the opposite. So let's use O to represent that. Then this side becomes what? The adjacent. Let's use A to represent that. Then we said that the sine of that particular angle given is going to be what? Opposite on what? The hypotenuse. So mean that if I take the sine of this angle, it should be opposite on what? This hypotenuse. Alright, now let's transfer this knowledge to the problem given, this figure 2 here. Now this is the right angle side. So this angle here is facing the longest side, which is 13 units. It means that this side is what? The hypotenuse. Now the angle A is placed here. Remember we are talking about sine A, cos A. So this, our main focus is going to be on this. So since this angle is facing this side, this becomes what? Our opposite. Now this side is going to be what? The adjacent. The adjacent. So it means that when we are going for sine A, it's going to be what? Sine A will be equal to what? Opposite on what? Hypotenuse. So the opposite is 5 divided by what? The hypotenuse, which is what? 13. So sine A will be what? 5 on 13. Cos A, adjacent on what? Hypotenuse. Adjacent on what? Hypotenuse. So that one will be what? 12 on what? 13. Then the tan is opposite on adjacent. So opposite is 5 divided by what? The adjacent is what? 12. And that will be what? 5 on what? 12. Yes. Simple as that. Now we have sec, which happens to be the reciprocal of what? Cos. The reciprocal of what? Cos. So since cos is equal to adjacent on the hypotenuse, which is 12 on 13, it means that the sec A will be what? 13 on what? 13 on what? 12. Now the cosecant, which happens to be the reciprocal for the sine. Reciprocal for what? The sine. But sine is equal to what? Opposite on the hypotenuse. It means that cosecant to be what? adjacent on what? Sorry, hypotenuse on what? Opposite. So we have hypotenuse being what? 13 on what? Then we have the opposite being what? 5. So it is going to change from what? 5 on 13 to what? 13 on 5, being the cosecant A. Now the cot, which happens to be the reciprocal of what? The tan. So this is going to be what? Tan is what? Opposite on what? Adjacent. Opposite on adjacent. So in this case, our cot will be what? Adjacent on opposite. So 12 on what? 5. So let's go through. So from the diagram, the side adjacent to the angle A is 12, and the opposite side to angle A is what? 5, and the hypotenuse is what? 13. Always the longest side, which is opposite to the right angle. So meaning that the hypotenuse is always the longest side, which is opposite to the right angle. Now the first part that we just discussed, now recall that sine of an angle is equal to the side opposite to the angle divided by what? The opposite, the hypotenuse, sorry. So therefore sine A will be what? Opposite to A divided by what? Hypotenuse. And the opposite is 5 on what? Then we have the hypotenuse being 13. Same way, cos is what? Adjacent divided by hypotenuse. So we're going to have 12 on what? 13. Then the same way, tan is what? Opposite on what? Adjacent. So that one to what? 5 on what? 12. Now we have sec, which happens to be the opposite of what? The cos. The opposite of what? Cos. Now, cos is 12 on 5. So the sec will be what? 13 on what? 12. So cos A is 12 on 13. So sec A will be what? 13 on 12. Meaning this is the reciprocal. So this. So cos, the sec here is the reciprocal of what? The cos. So if cos is 12 on 13, then sec A will be what? 13 on what? 12. Alternatively, sec A can be equal to 1 on cos. And already we know that cos is what? Cos is 12 on what? Cos A is what? 12 on 13. So 1 divided by 12 on what? 13. So we have 1 divided by 12 on what? 13. Now, so 1 divided by this. Find the reciprocal of this. So now you have 13 on 12. Simple as that. Now this is what? The reciprocal of what? The sine. But sine is what? Sine is opposite on hypotenuse. Opposite on what? Hypotenuse. So it means that the cosecant to what? Hypotenuse on what? Opposite. Now we have 13 on what? 5. So sine was what? 5 on 13. So we have 13 on 5. The same way, cosec. Now it is the same as what? 1 on sine A. 1 divided by 5 on 13. The same way, you maintain this, you change the sign to multiplication, you find the reciprocal of this, then you multiply. So 1 times 13 will give you what? 13 divided by 5. So you have 13 on what? 5. Alright, so the next one is what? Cot. The next one is cot A. Cot A, which happens to be the reciprocal of what? Tan. So tan is opposite on adjacent. So this one is going to be adjacent on opposite. So we have 12 on what? 5. Alternatively, tan 1 on tan A is the same as what? Cot A. So we have 1 on 5 divided by 12. You maintain the 1 here. You change the sign to multiplication, find the reciprocal of the next term, then you multiply. That's why we had this here. So that is the answer. So it's quite simple as that. Now we have example 2. The diagram below shows a right angle triangle plate of dimensions 3, 5, and x. Use this information to answer the questions. Alright, so let's see. This is a right angle triangle. To be able to determine some of even all the trig ratios, we need to know all the sides. Now, since this is a right angle triangle, we can apply the Pythagoras theorem. So which says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So looking at it, this is the right angle side, so which is opposite to this side. So it means that this side is what? The hypotenuse. So meaning that the square of this, so 5 squared will be equal to what? 3 squared plus x squared. Yes. So it means that we are to get the value of this side here. So using the Pythagoras theorem, that's where, and you can only apply this theorem when you have a right angle triangle. If it is not a right angle triangle, please don't go for this theorem. So this 5 squared is what? Going to give us what? 25. So we have 25 being equal to 3 squared is what? We have 9. Then we have x squared. X squared. Now we have 25 here. So we can decide to subtract 9 from both sides to get rid of this. So 25 divided minus 9 will give us what? 16 here. And this side minus 9 will be left with what? X squared. We're left with x squared. Okay. We're left with x squared. So we have x squared here. Alright. We want x, not x squared. So we take the square root of both sides. And the square root of 16 is what? 4. So our x will be equal to what? 4. Meaning that this side is what? 4 units. Yes. So we know all the sides. So we can easily go by these things. Now you were asked first one to find the value of x, which is going to be simple as we just did here. Yes, that is the value of x being what? 4 units. Now you have to find cot, and we know that cot is the same as what? So we have cot theta. Cot theta will be equal to what? Cot theta will be equal to what? 1 on what? Tan theta. Alright. Or simply, we know that cot is what? The reciprocal of what? Tan. But tan is equal to what? Opposite on what? Adjacent. So we have opposite on what? Adjacent. So tan will be what? 5 on 3. So cot theta will be equal to what? 3 on 5. Simple as that. Sine, opposite on hypotenuse. Opposite. Opposite. This is the angle. So, sorry, let's check the first one. We had cot. When we consider tan, tan is what? Opposite on what? Tan is opposite on adjacent. So opposite on what? Adjacent. Opposite on what? Adjacent. So we're going to get this side is 4, so we have 4 on what? 3. 4 on 3. Okay, 4 on 3. So it means that the cot theta will be equal to what? This is not correct here. So let's rub all this and do it again. Okay, so we know our x to be what? 4. Now let's go cot. Now if you know that tan is opposite on what? Opposite on adjacent, which is opposite on adjacent, we have x on what? The 3. But x is 4, so we have 4. We have 4 on what? 3. 4 on 3. Alright. So we have 4 on 3. But the cot here is the reciprocal of what? The tan. But this is tan what? Theta. So cot theta will be equal to 3 on what? 4. Simple as that. Okay. Sine is opposite on hypotenuse. Opposite on hypotenuse. Opposite, which is 5 on hypotenuse, which is what? Opposite is 4 and hypotenuse is 5. So we have 4 on what? 5. 4 on 5. Then we have to find theta. Now the thing is, we know that let's say sine theta. Taking sine theta is equal to what? Opposite on the hypotenuse, which is 5 on 1. So sine theta. Now to get this theta here, theta will be equal to sine inverse of 4 on what? 5. Yes. Alright, so just as we did, using theta as our reference, so I'm going to read this. Let's first assign names to the side of the triangle. The side of the triangle opposite to theta is x. The side adjacent to theta is 3, and the hypotenuse is 5. So we find the x, we apply the Pythagoras theorem. This gives, we have x squared, just like we did. We have x squared plus 3 squared equal to what? 5 squared. So we have this to transpose. Then we have 25 minus 9, we have 16. So square root of 16 equals 4. Then cot is equal to what? 3 on what? 3 on 4. Then we have the sine being what? 4 on what? 5. 4 on 5. Now from the we have sine theta equal to this. So this means that theta will be equal to sine inverse of what? 5 on what? 4 on 5, which is equal to 53.13 degrees. So it's as simple as that. Thank you for watching.